Hello, this is a series of 10 short videos just to show you how to answer some of the math skills in chemistry. Because if you can master these, you can really hit those top grade 8s and grade 9s. So let's go through them first of all. As you'll see, what I do when I'm answering these maths questions is I always highlight the parts that are important, and it's usually to do with the numbers. And then if there's anything to do with an equation, luckily in this question we're being given the equation, then I always tend to try and put it into a triangle because it's much easier to try and manipulate. So a student adds potassium chloride to 0.40 decimeters cubed of water, which is the solvent. She produces a solution of concentration 9.2 grams per decimeter cubed. Using the following formula, calculate the mass of potassium chloride. So, if I look then, what I'm actually being given is I'm being given the concentration, I've got that there, and I'm being given the volume of the solvent, I'm being given that there. I'm not actually being given though the mass of the solute, and that's the bit that I want. So all I've done is put that into a triangle, and the part that I want is at the top. So if I put my thumb over that, then my calculation is concentration times volume. Concentration times volume. I write down the equation first of all, because you could sometimes pick up a mark for that. I put the numbers in, 9.2 times 0.40, and that's 3.68 grams. And I've just rounded it to one decimal place, because most answers are one decimal place unless it actually states. So that was a straightforward calculation. This second question then, it says the table below shows the volume of water processed by a water treatment plant each day over a 5-day period. Calculate the mean volume of water processed by the plant per day and give your answer in standard form to 3 significant figures. Standard form to 3 significant figures. Now that, you have to be careful because that comes up a lot in exams right at the end of the question, and lots of people just miss it because they don't read the question properly. So make sure you read the question properly. So this is a straightforward working out a mean. So I just take the 5 numbers, add them all up and divide it by 5, and I get this number here. Now it says 3 significant figures and in standard form. So if I take this back 6 places, 1, 2, 3, 4, 5, 6. I've then got 4.34 as my answer, but then it's times 10 to the power of 6 because I've now put it into standard form as well. And that's quite a straightforward way to do that, but that question's actually worth 3 marks, so an easy 3 marks to pick up there. So let's have a look at question 3 then. Question 3. The percentage mass of an element in a compound can be calculated using the following formula. Percentage mass equals the number of atoms of the element divided by the mass of the compound. The mass of the compound is calculated by adding up the atomic mass of the atoms in that compound. Calculate the percentage mass of oxygen in the compound shown below. Well, there's our compound. We've got to work out first of all what the actual formula is. So we've got to add up, what have we got? Right, we've got 3 carbons. So all I'm doing here is I'm writing a list because I don't want to miss out any of the stages, or I don't want to miss any of the actual elements. I've got 1 oxygen, and then I've got 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. Okay, I know that it tells me here the atomic mass of each particle. Carbon is 12, so 3 times 12 is 36. Oxygen is 16, and I've got 1 of those, 1 times 16. And then hydrogen is 1, and I've got 8 of those, so 8 times 1 equals 8, and I add them all up, and I get to 60. Okay, so I've got my overall mass, okay, which is the bit I need for the bottom here. Now, all I want to know is what the mass of oxygen is, because that's what the question's asking. It just wants to know about oxygen, it states it here. So I'll take 16 times 100 divided by the total mass, 60, equals 26.66. However, I put it to one decimal place again, and it's 26.7. So all I've done there is I've taken it in stages, work out the formula, work out the mass, put it into the calculation, and get to one decimal place. The last question in this section is looking at surface area. The diagram below represents a nanoparticle. Its dimensions are given in nanometers. calculate the surface area to volume ratio of this nanoparticle as a decimal. Well, the surface area, first of all, is if I take the width times the height, 8 times 8, but then, once I've worked that out, I multiply it by 6 surfaces, because I've got 6 surfaces, and I get 384, whereas the volume is the width times the height times the depth, and that comes to 512. 384 divided by 512 equals 0.75 nanometers. Again, I've rounded it up to 1 decimal place, and that's 0.8. There's your first test and the first 4 questions for you to see how to answer them.